In this video, we will be presenting solutions to homework number 3. In the first two problems, number 14 and 18, we simply want to compute the value of the number to the exponent given. So starting with number 14, we're looking at 1/2 to the -1. A -1 exponent means you place the value under the denominator 1. So this is the same as 1 over 1/2, which equals 2. A nice easy thing to remember is if you have a -1 exponent, you can simply flip the numerator and the denominator. In fact, to get rid of any negative exponent, you can simply flip the numerator and the denominator, leaving the exponent in its positive version. That's number 14. Let's go ahead and take a look at number 18, which is 16 to the 3/4. When dealing with a fractional exponent, you have two options. You can write this as 16 cubed to the 1/4, or you can write it as 16 to the 1/4 cubed. And you have to decide which one of these you think is easier to do. I'm going to choose the second one because raising 16 to the 3rd power will give me a large number, while 16 to the 4th power is easy to compute. What times what times what times what is 16. So 16 to the 1/4 is 2, and now all I have to do is cube it to get 8. You could, of course, go this way, but you're going to need to multiply 16 by itself 3 times and then figure out what the 4th root of that is. So these problems are easy if you make the correct choice of which to put on the which part of the fractional exponent to do first. For the next two problems, number 34 and 39, we're going to use exponent laws to compute the values. Let's start with number 34. There's multiple ways to approach many of these types of problems. The trick is to pick the correct exponent rule and apply it. The nice thing is, many times, it doesn't matter which one you apply. As long as you work at it for a little while, you'll get to the answer. So we're going to start by using this rule, which states that if you have the same base and you're dividing, you can simply subtract the powers. And that is exactly what we have here. Our base is 3, our powers are 5/2 and 1/2 respectively. So this is going to equal 3 to the 5/2 minus 1/2. And 5/2 minus 1/2 is 4/2, and 4 divided by 2 is 2. So we're left with 3 squared, which is 9. And we have answered our first problem. So let's move on to number 39. For 39, we're going to apply the same rule. Our base this time is 7, and our exponents are 4/3 and 7/3. So we have 7 to the 4/3 minus 1/3, which is 7 to the 3/3, which is 7 to the 1, which equals 7. And we have our answer. And we're ready to move on to the next problem. For the next two problems, number 50 and 59, we're going to be simplifying these algebraic expressions so that we have no negative exponents and that we have no parentheses. So let's start with number 50. When dealing with radicals, I find it's easiest to convert the radical into a fractional exponent. So this becomes 1 plus x to the 1/2 times 1 plus x to the 3/2. Next, we would like to combine these two things, so we're going to make use of this rule, that if we have two things with the same base and we're multiplying them, then we simply have to add the exponents. And that's exactly what we have in this situation. We have x plus 1 as the base in both of these. So we can go ahead and add the exponents of these two things. So 1/2 plus 3/2 is 4/2, which equals 1 plus x squared. Now we simply have to multiply this out, giving us 1 plus 2x plus x squared. We have to multiply this out in order to get rid of the parentheses. And we're done with this problem. Okay, so now we can move on to number 59. 59 is essentially the same thing, except we want to get rid of both of these radicals. So we can rewrite this as x to the 1/3 times x squared to the 1/3. Now combining these two exponents, we get x to the 1/3 times x to the 2/3. And the the rule we made use of right there on that step was that a to the n to the m equals a to the n times m. So for us, a was x, n was 2, and m was 1/3. So I multiplied 2 times 1/3, which gives me this. Now we can continue with the problem. We have the same bases, so all we have to do is add the exponents. And x to the 3/3 is just x. So we made use of this rule again for moving from this step to this step. For number 71, we want to find the missing factor. More specifically, what do I need to multiply this 1 over square root of x by to get me square root of x minus 1 over square root of x? So writing the right-hand side, I'm looking for something that goes inside this parentheses that when I multiply those two things together, I get square root of x minus 1 over square root of x. What has to go inside here? There should be two values inside there because I have two values here. When I multiply this first value by this, I should get square root of x. And when I multiply this second value by 1 over square root of x, I should get this. The second one is not so hard to see. I need a 1 over square root of, a 1 in this second position. A minus 1 more specifically. Because when I multiply 1 over square root of x by minus 1, I get minus 1 over square root of x. So the next thing I need to do is figure out what to put here. Let's go ahead and do a little scratch work here to look at what happens when we multiply 1 over square root of x by different things. If I multiply 1 over square root of x by square root of x, I end up with 1. And this is not what I want. So what I'm going to need is more than square root of x here. I'm going to need 2 copies of square root of x. If I multiply 1 over square root of x by square root of x times square root of x, these two will cancel and just leave me square root of x. So now I found what I need here. I need square root of x times square root of x. Because when 1 over square root of x multiplies, 1 will cancel, leaving me with the square root of x here. So what I need is square root of x times square root of x. And I need to put that here. Well, square root of x times square root of x is square root of x squared. Which is the same thing as x. So let's go ahead and put that inside here. Sometimes this is a little difficult. One thing you can try is guessing a few things to put inside here and multiplying and see if you get the right answer. Similar to the last problem, in this problem we're looking for x to the negative 1/3 times what will give us this side here. So I'm looking for what goes inside this parentheses so that when I multiply this, I get 2x to the 2/3 minus x to the minus 1/3. Notice how I have two pieces on the right-hand side, so when I multiply, I'm going to need two pieces on the inside. When I multiply x to the negative 1/3 by the first piece, I should get 2x to the 2/3. And when I multiply x to the negative 1/3 the second piece, I should get x to the negative 1/3, or negative x to the negative 1/3 because of this. So the second piece is easy to figure out. It needs to be minus 1, because x to the negative 1/3 times minus 1 equals x to the minus 1/3. So the difficult part is figuring out what goes here. That is, so what we need to figure out is x to the negative 1/3 times what equals 2x to the 2/3. Since we have a 2 on the right-hand side and no 2 on the left-hand side, we're going to have to put a 2 here. Since we have x to the negative 1/3 and x to the 2/3, namely the powers on the exponents change, we're going to have an x to some power here, so that the 2 combines to give us this 2, and the x's go together to give us this. Now, if we multiply out the left-hand side, we have 2x to the negative 1/3 plus question mark, and we're hoping this equals 2x to the 2/3. One important thing to remember is when combining things with the same exponent, or at the same base, we simply add the exponents. So this plus this. That's why I need an x to some power here so that I can change the power, and I need a 2 here so I can pick up the constant. So what I'm asking is, just looking here, negative 1/3 plus what is 2/3? Negative 1/3 plus what equals 2/3? And solving this equation, we get our question mark needs to equal 1. So putting all of that together, the 1 from here is where the question mark is. So this should equal 2x. So now we know what to put inside here. This box needs to be what goes right there. And we end up with $2x right here. And since this was sort of a long problem, it's worth coming back and checking to make sure we did it correctly. So let's go ahead and multiply out x to the negative 1/3 times 2x minus 1 to double check that we get what we expect on the right-hand side. So multiplying the x to the negative 1/3 by 2x, I get 2x to the 1 minus 1/3. And when I multiply the x to the negative 1/3 times minus 1, I get minus x to the minus 1/3. And just to reiterate again, the reason I have 1 plus x to the negative 1/3 is because I need to add these two exponents. And maybe it's nice if I write the exponent of 1 there so you can really see. And then cleaning up the right-hand side, 2x, 1 minus 1/3 is 2/3, minus x to the minus 1/3. And we're done. This here is exactly what we wanted here. So this is the answer. One thing that's worth doing now is going back and revisiting the last problem and changing the square root of x into x to the 1/2 so you can treat the whole problem like this one with the fractional exponents. Now moving on to section 1.1, we're going to do problem 8, which is to find the equation of the line with slope 2, which has the point 1, negative 2 on the line. So here it's most easy to make use of the point slope form, which is named nicely because to put an equation into point-slope form, all you need is a point and the slope, which is what we have, a point and the slope. So a point on the line specifically. Let's dissect this for just a second. M is the slope, and the y1 and the x1 go together to combine, or to be the point x1, y1 on the point, on the line. So now all we need to do is fill in the details with our particular pieces of information. So we have y minus y1, so that is the y value of our point, which is minus 2. Be careful with the parentheses to make sure that you combine the negative and the negative 2. And this should equal m for us, which is the slope, 2, times x minus x1. x1 for us is 1. Once again, the slope, 2, is going in the m position. The y1 is the negative 2 here, and the x1 is the 1 here. And now we have our equation in point-slope form. So we have y plus 2 equals 2x minus 2, and moving the 2 over, so this looks like a nice equation of a line, we have y equals 2x minus 4. And that gives us our answer. Moving on to number 11, we want to find the equation of the line which contains the points 5/7 5 and negative 5/7 negative 4. It helps, I think, to write down the equation for a line, and I find using point-slope form is often the easiest because all you need is a point and the slope. We have 2 points, in fact, so we can definitely get a point, and all we need to do is find the slope. If you have 2 points, finding the slope is straightforward. Remember what the slope is. It's the change in y over the change in x. So the change in y is negative 4 minus 5 over negative 5/7 minus 5/7. Remember, it's not important whether you do this y minus this y, or this y minus this y on top, as long as you match it on the bottom. So I'm doing the second point minus this first point's y value. So I have to do the same thing on the denominator, the second point's x value minus the first point's x value. So going ahead with this, I get minus 9 over negative 5/7 minus negative 5/7 is negative 10/7. And I can go ahead and clean this up. The negatives will cancel, and I'll have 9 times 7 over 10, which equals 63 over 10. And now it's simply a matter of filling in the details of the formula. So my y1 is, and it doesn't matter which point you pick here as long as you're the same for x and y. So I'm going to go ahead and go with the first point. The slope we just figure out is 63 over 10. And x1 is 5/7. Just make sure you get the right x1, the right x value to match the y value. So either both of these or both of these. And now we have our answer. And of course we can clean this up to be in slope-intercept form. So we have 63 over 10 x minus 63 over 10 times 5 over 7. And notice the 5 can cancel with the 10, giving me a 2 in the denominator. And the 7 can cancel with the 63, giving me a 9 in the numerator. So my final answer is y equals 63 over 10, x minus 9 halves. Number 14 is similar to the last problem, but I'm going to do it with a different method so you can see a different way of doing it. Rather than starting with point slope form, I'm going to start with slope-intercept form. Of course, m is the slope, and b would be the y-intercept. All right. So in order to fill this equation in, I need the slope and I need the y-intercept. It's best if you start by finding the slope. To find the slope is the same method as before. We need to take the change in y over the change in x. So I'm going to take the second value, or the second point, and subtract from it the first point. So 1 2/3, which is the second point, and I'm going to subtract negative 1/7 and negative 1/2. And this should give me 1 minus a seventh is 7 over 7 plus 1 over 7. So I'm finding a common denominator here. And I want a common denominator for the fractions in the denominator. And I'm going to go with 6. So I'll have 4 over 6 plus 3 over 6. If you need to take a moment and pause the video to work out how to get these common denominators, go ahead. Putting the numerators together, I have 8 over 7, and putting the fractions in the denominator together, I have 7 over 6, and this simplifies to 8 times 6 over 7 times 7, which is 48 over 49. And I have found my m value. So the next thing I need to do is find the intercept. In order to do that, you want to come back to your slope intercept form and fill in the details. So notice my slope, I figured that out. So I have y equals 48 over 49, x, and I still need to figure out the b value. But once I have this, I simply choose any point that I started with, either this one or this one, and put it into this equation. So either I can choose to plug this one in for the x and y values, or I can choose to plug this one in for the x and y values. I'm going to go ahead and go with this equation here, or that point there, because I like the numbers better. So plugging in the y value for y, I have 1 equals 48 over 49, and I guess this should be a 49 here, not an x. So we have, back to where we were before, the 1 is being plugged in for the y. I'm keeping the 48 over the 49 here. I'll plug the 2/3 in for the x. And I'm going to need to add to that b, which is my unknown. So to do this, to find the b, all I have to do is solve this for b. So I get 1 equals 32 over 49 plus b. And moving that over to the other side, moving the 32 over 49 to the other side, I get 49 over 49 minus 32 over 49 equals b. Notice I changed the 1 into a 49 over 49, so I had a common denominator. And this gives me 49 minus 32 is 17, over 49 should equal b. So now all I need to do is put this b back into my equation here, and I'll have my final solution. So that's y equals 48 over 49 x plus 17 over 49. You can compare this to the last method and see which you think is easier. For problem number 25, we will be finding the equation of the line perpendicular to the line given here, which goes to this point here. First, let me talk for just a second about what it means to be perpendicular. Two lines are perpendicular if they intersect at 90 degrees. As the lines I've shown here, in this example, they intersect each other with a 90-degree angle. Now there's many lines that are perpendicular. In fact, any rotation of these lines would be perpendicular as long as the angle between them stays the same. So what we're really saying when we're talking about perpendicular lines, or when we're requiring lines to be perpendicular, is a relationship between the slope of this line and the slope of this line. So two lines are perpendicular if they have slopes with the following relationship. The slope of one line is equal to the negative of the reciprocal of the slope of the other line. So the slope of one line is equal to the negative reciprocal of the slope of the other line. If that's the case, then the two lines are perpendicular. So, if we are given a line, and we want to find the equation for a line perpendicular to it, we can already figure out what the slope of the next line is. So let's go ahead and do that for our problem. So, before getting started, since we're going to need to know the slope of the line here so that we can figure out the slope of the line perpendicular to it, let's go ahead and rewrite that solved for slope-intercept form, or also in this case, point-slope form. So now that we have it this way, we can see what the slope of this line is. So this line has slope -1. So what we would like to do is find the slope of the line perpendicular to this one. And once again, whenever I'm finding the equation of a line, I like to start off by writing the formula for a line and then filling in the values that I need. This way I always know what I'm looking for. I find it's easiest to start with point-slope form. So I want to find the equation of a line. I simply need to find m and a point on the line to find the equation. M is very easy to find because we know this equation, this line should be perpendicular to this line, and the slope of that line is -1. So for us, m should equal -1 over -1. I'm using the formula here. And this just equals 1. So now we have the slope of the line that we want. We also already know a point on the line because it was given to us in the question. And that point on the line is 2, 0. So we can simply fill in the details we need. Y minus y1, so y1 for us is 0, equals m, so m for us is 1, x minus x1. And now we have the equation of the line. And we can easily rewrite this in slope-intercept form if we want. And we're done. In problem 31, we need to match the equations of the lines to the graphs of the lines. Before getting started, I think it's best to change the equations of these lines into slope-intercept form so you can read off the intercepts and the slopes much easier. So let's go ahead and do that. A should become y equals minus x plus 1. B should become y equals x minus 1. C should become y equals minus x minus 1. and D should become y equals x plus 1. Now that we have them in this form, it should be much easier to match the equations to the graph. So let's go ahead and do that. Okay. Starting with number 1, letter A, we can see that we have a negative slope and a positive intercept. So the negative slope already discounts A and B, since these have positive slopes. So now we have to look at C or D, which both have negative slopes. C has a positive intercept, so it's a good match for this one, while D has a negative intercept, so it is not a good match for this one. So A has to go with C. And we have A is paired with C. All right, moving on to the next one, we have a positive slope and a negative intercept. So here's our two positive slopes, and this one has a negative intercept while this one has a positive intercept, so this is the one we need. So B should match with B. Next, let's look at C. C has a negative slope and a negative intercept, so we've got negative slope, positive intercept, negative intercept, so it should be D. And finally, we're looking at positive slope, positive intercept. So positive slopes are here, positive intercept is here, negative intercept is here, which means A is our choice, and we have our solution.